Hello, everyone, and thank you very much for joining us this evening. My name is Jeff Simon. I'm president of Social Flight, and we are very happy to be hosting tonight's presentation, which is addressing the safety concerns that we're talking about here identified with technically advanced aircraft systems. This is certainly a topic which is interesting to a lot of folks as we see all of these new avionics come across the market, which of course have fantastic safety features, but also a lot to learn. And I'd like to express my appreciation for Tom Harper, Director of Marketing at Avidyne, for joining us. Avidyne is a strong supporter of Social Flight, and we really appreciate that. The fact that we exist because of companies like Avidyne and are able to support general aviation by providing all of you with a free app and all the reasons to get you flying more, which ultimately is our mission. We feel that if we can get people flying more and we can support local organizations, type clubs, EAA chapters, and the like by getting more people to their events and expanding that we're helping all of general aviation. That's certainly our goal, and I really appreciate the support, and we all do, of Avidyne, and for joining us this evening. There will be a recording available after the presentation, and you will get an email that sends you information about that so that you can refer back to it. And the recording will be available through Social Flight. In addition to that, I would just like to let you know that there's also a chat section here. Now you can get your audio through either the dial-in number that's out there or directly through your computer, and there should be instructions as you register and log in order to do that. But feel free to post your questions on chat, and we will keep an eye on that, and we will address them at the end of the presentation, try to get everything possible answered. And my understanding from Tom is that there's also something that Avidyne's doing for people that attend, I think, which will be a pretty good benefit if anyone is considering one of their products. And so with that, I would like to introduce Tom Harper, and thank you so much for joining us tonight, Tom.
Thanks, Jeff. I appreciate it. I want to thank you and folks at Social Flight for allowing me to put on this seminar, and thank you guys for taking your time out of your busy schedule to join us this evening. I hope you find it informative, and I guess we're ready to roll. If you're ready, Jeff.
We're all set. Thank you.
All right. Thanks. All right. Again, my name is Tom Harper, Director of Marketing for Avidyne, and what we're going to do today is talk about some of the safety concerns that were identified in the FAA and Air Safety Foundation Technically Advanced Aircraft Studies, and how Avidyne has taken those findings and used them to develop products that address those very concerns. I can move through the slides here. There we go. So I'll kind of tell you a little bit about what the technically advanced aircraft is, what the definition is, and some of the findings, and then how we challenged our engineers to kind of meet some of those findings and overcome those issues that were identified, and then talk about the actual product itself and how that came to fruition. So what is the technically advanced aircraft study? Well, first of all, it was initially as a study by the FAA. There was actually a team put together, the TAA Safety Study Team, back in August of '03. You got to remember, this is the advent of Cirrus coming out with the Avidyne Integra systems, and then about 6 or 8 months later, Cessna started producing 172s, 182s with the G1000 system. And but even prior to that, there were technically advanced aircraft, non-PFD aircraft. But incident to the after the August 2003 study, there were follow-on studies by the AOPA Air Safety Foundation in '05 and '07. And while these studies, I'm bringing you data that's arguably 10 years old in some cases, it lays the groundwork for how we got to where we are today with the IFD540 specifically. So I hope you find it enlightening. First of all, it was the main purpose of the study was to obviously reduce fatal accident rate in the U.S. and kind of identify some of the key causal factors in those accidents. But first of all, what is a technically advanced aircraft? The best way to describe it is basically any aircraft that has an IFR certified GPS, a moving map display, and an integrated autopilot. So notice that doesn't include the PFD per se, although most of those after 2003 were all PFD equipped. In general, TAAs are aircraft in which the pilot interfaces with one or more computers in order to aviate, navigate, and communicate. So you can see that encompasses a lot of airplanes. Of course, nearly all new aircraft since 2003, again, these are quotes from the study, could be qualified as glass cockpits because they also have the primary flight displays that have replaced the traditional six-packs. You can see here, these are considered technically advanced aircraft. This is going back to when, after the General Aviation Revitalization Act was signed in the mid-90s, Cessna started building airplanes again, and they had the KMD550 and a KLN94 and a KP140 autopilot. So that met the criteria. It had an IFR GPS, it had an MFD, and it had an integrated autopilot. So even though it was a six-pack airplane, that was considered a technically advanced aircraft. Cirrus had come out with their new aircraft, and they had the big, originally had the big RNAV MFD along with dual 430s, and they put an STEC system in a lot of those airplanes. So that, again, technically advanced aircraft without PFDs. The follow-on to that, of course, was Cirrus was the first technically advanced aircraft in light GA with a primary flight display with the Avidyne Integris PFD and MFD, again, dual 430s and an STEC autopilot. And then subsequent to that, other OEMs, the Cessna, Mooney, Diamond, and then Cirrus went to the Perspective in 2007, 2008 timeframe. But basically the G1000 systems are all GNS 430s with the faceplate cut off and kind of the same software embedded into the big screen, but it behaved and operates very much the same as a panel-mounted 430, 530. There are also older aircraft prior to that that have been retrofitted and become technically advanced aircraft. You know, you take an older aircraft like a Bonanza here, you put in an MFD, you put it in an IFR GPS, you put it in an autopilot, and whether it has an Aspen PFD or not, it can still be classified as a TAA. And of course the concerns, the safety concerns are all these cool new gadgets are sucking up resources, they're pilot resources, and resulting in a lot of head downtime because of all the cool new gadgets. So here's the primary findings. The predominant TAA system-specific finding is that the steps required to call up information and program an approach in IFR-certified GPS navigators are numerous, and during high workload situations, they can distract from the primary pilot duty of flying the aircraft. So basically they're saying pilots are spending too much head downtime programming their FMS. They followed that to say, by the way, MFDs in these accident aircraft did not appear to present a complexity problem. The team also believes that PFDs are not likely to present a complexity problem. So it wasn't the PFDs and the MFDs that are causing the concern, it's the FMS. TAAs provide increased available safety, which is an interesting way of looking at it. They believe there's a lot of potential for safety, but it has to be unleashed or exploited by additional training and other ways in order to take advantage of. Obviously, by having an MFD that you know where all the special use airspace is, if you have XM, you know where the weather is. You've got an IFR GPS, you can stay right on course and not deviate. There's a lot of power pent up in the technology, but if you're not using it properly or not trained adequately, the pilot isn't necessarily getting the available safety that he paid for. So anyway, we took all of these data, and obviously the big outtake for us was, a takeaway, was that these FMSs are just hard to use and they require a lot of head downtime. Again, their findings suggested that manufacturers, such as Avidyne and others, should make available and TAA owners should install systems to improve the pilot's awareness of hazards to flight and the status of automation systems, and to simplify the process of executing IFR approaches. So those are ways that we as manufacturers can improve the safety record and make technically advanced aircraft easier to use and therefore safer. So we took that study and we took it to heart, and we challenged our engineering team. Can we develop an FMS that reduces heads downtime? Can we simplify the process of executing IFR approaches? Can we make smarter systems that protect the pilot? Those were the challenges that we set out as far back as 2003. Remember, all the Integra-equipped airplanes that were shipping out of Cirrus, we had probably close to 5,000 Integra systems that were shipped. All of those came with a Garmin stack of radios, and it's the FMS that was basically indicated in the study as being the root cause, if you will, or the problem in a lot of cases with head downtime. So we thought, yeah, that we have a way we can do that. We know we can answer these questions affirmatively, and let's get to work doing that. So the first thing we did is we made the next generation of integrated flight deck, which will be called Integra Release 9, and it incorporated our FMS 900W, which was a much easier to use flight management system. And if you look in the pedestal area here, you can see that our FMS keyboard displaced the dual 430s that were in the panel. We also replaced the old displays with new displays, and each of those displays had our own radios, our own GPS, our own AHRS. But so we got rid of the 430s and put in an FMS system that really addressed a lot of the concerns of the TAA study. We've taken that same technology now and we've designed it into a series of mark-width products that we can sell in the aftermarket, including the IFD540, the IFD440, and also I should mention our DFC90 autopilot, which we had the DFC100 with R9. The DFC90 is our retrofit autopilot, and it also addresses some of the autopilot aspects of TAA because with cool features like envelope protection and a straight and level button, airspeed hold, those kind of things that make flying simpler and relieve workload for the pilot. For the sake of this webinar, we're going to focus more on the 540, and which is a derivative of the FMS out of R9. So when we looked at the UI process, we've got a system that's developed by pilots for pilots. That's kind of cliche in our industry, but the fact is virtually all of our engineers that touch this product are all pilots. Virtually everybody in the sales and marketing team are pilots. All the leadership team are pilots. We take this very seriously, and more importantly, Avidyne as a company is exclusively focused on avionics for general aviation aircraft. So that's really all we do. So we apply the engineering consistency and the discipline that engineers bring to it, and look for consistent operation that's going to breed ease of use. So, and we also had a bunch of time and motion studies and evaluating an ABC keyboard versus a QWERTY keyboard, and sitting pilots and students, pilots of all levels, and aviation students from our factories in Melbourne, Florida. FIT, Florida Institute of Technology, is down there. We got a lot of their students to come over, and we ran tests with those guys just to see what was simpler, where were they making errors, and how could we improve the system. Graphical aids, using color-coded rows, putting pictorial views of the holds and procedure turns right into the FMS, and I'll show you some examples of these. Nice, easy-to-read fonts and plain English terminology. A flat menuing system, none of this nested menus where you're drilling down 4 and 5 levels deep. And again, unambiguous controls. Gosh, was I supposed to push the button in before I turned, or was I supposed to push this button before that button? Ways that we can take all the guesswork out. You don't need to memorize. You don't need a secret decoder ring. Even most of our customers are kind of low time. They're flying less than 100 hours a year, and it's hard to memorize how to operate these things. So you need to make it intuitive so that at a glance they can figure it out, and that's really what our goals were. When I talk about color coding, here's a look at our FMS, which looks significantly different than anything you've seen on a 530. The active leg is magenta. The destination or the airport leg is in blue. You can see the scroll bar here. This means the flight plan is this long, but we're viewing what's blue here. The blue block is representing how much of the flight plan we're viewing, and the active waypoint is represented here. So it makes it easy to tell where you're at in the flight plan at any given moment. You got plain English readouts. How you're supposed to get to the end point is laid out. You fly course 118 degrees. Instead of just having 118 up there, we tell you what to do. You're going to climb 500 feet, fly heading 360, and intercept the next leg. It's all plain English, and it makes it really obvious what to do next. Even our holds, we give you a graphical view of the direction of the hold, etc. We also have an insert cursor. How many times have you gone to enter a waypoint in to a flight plan, and on the older boxes you move the cursor over a waypoint, and when you start typing the new one by spinning the knob, is it going to go in before the existing waypoint or after it? You don't know. It's very obvious with an insert cursor. It's unambiguous. It takes the guesswork out of it. We developed what we call a page and tab user interface, which allows us to have a flatter menuing system that I can basically get to any page in the system in 1 or 2 clicks. There's no hidden pages. It's obvious what page you're on. It's outlined in cyan. In this case, we're on there's 3 main pages here, FMS, NAP, and AUX, and we're on the flight plan tab. Now you compare that with 530. Notice we're on the nav pages. We're on nav page 2 for those of you familiar, but you don't really know what's on nav page 3, 4, or 5 until you go there. You either have to memorize it or you have to do a lot of hunting and pecking. Do I move the inner knob to get there, or do I move the outer knob? I found as a user of the 430 and 530 and even the KLN 90, I tend to have a lot of do-overs. I can get through the box pretty okay because I use it a lot, but I have a lot of do-overs even as a proficient user. And then if you compare it with the GTN, which is the newer touchscreen box from Garmin, it has the basic same underlying page theory as the Garmin GNS, but it's kind of reskinned with a graphical hierarchical menu system. It's still hard to tell what page you're on, what other pages are available. It's not grouped by subsystem, those sort of things. And then they jumped in with both feet with touch, and so they don't give you the option of having knobs and buttons, which we think is really important depending on your phase of flight. Geofill. This is an algorithm that Avidyne developed. It predicts the intended identifier based on proximity, based on the type of facility. It's context aware, so it knows if you're doing a direct to, if you're entering a waypoint into the flight plan. And it basically nominates the next waypoint after 1 or 2 keystrokes based on distance rather than just alphabetically searching in the database. We've found in doing extensive testing that geofills, when using the knob turns, it reduces the knob clicks and button pushes by as much as 75%. And even when using the keyboard, it showed a significant improvement as well. Here's a geofill example. Let me see if I can take you through it here. So it looks like we're building a flight. Notice on the map, I'm sitting at Melbourne Airport in Florida. But I'm building a flight plan. In this case, it looks like Albuquerque and the Socorro VOR and El Paso. If I were to type direct to and I typed the letter and I entered the letter D, the geofill is going to give me DHP, which is the Dolphin VOR, which is the nearest VOR that starts with the letter D, or the nearest actual nav aid. So it's going to give me something near where I'm at, which makes sense because I'm doing a direct to. Conversely, if I were building the flight plan and I typed in the letter D over here, it's going to nominate the Deming VOR, which is in New Mexico, and makes sense in the context of that flight plan. So by entering, 2 knob pushes, I bring up the FMS menu, and of course I can knob it in like I could with a 530. You remember the outer knob over here moves the cursor, the inner knob changes the value. The outer knob moves the cursor, the inner knob changes the value. So we can still enter that way on a 540. We also have a QWERTY keyboard, but for the sake of this discussion, we did it without it. So you compare that with the entering the same thing on a 530. It would require you to do the inner knob 8 turns, the outer knob a turn, then 13 inner turns, then 1 outer, then 14. You get the idea. Then you have to enter, and then you have to select DMN, the one in New Mexico, instead of the one in Germany. So you can see in this brief example the significant amount of head down time and knob clicks and button pushes required to enter a simple waypoint in the old system versus how we've come up with our methodology with geofill. And here we are with the keyboard. With the keyboard, it's 2 knob pushes and you touch the letter D. And of course our 540 has integrated Bluetooth and Wi-Fi. If you had a Bluetooth keyboard, which will be an option going forward, you could just reach down and type the letter D on your keyboard and it would automatically enter it. So it's literally 1 keystroke to enter a waypoint versus however many you want to total that up to. That's over 30. Another nice thing we implemented in the 540 and also in R9 FMS is that it's kind of continuous flight plan. There's no need to activate an approach. If you don't have a suspend mode, it'll automatically connect and activate the next leg, etc., unless you have a break. Here's an example here from Melbourne to Daytona Beach. And notice you can see here the flight plan goes to Smyra, and then we've loaded an approach, so there's a gap that we need to close. Expand that. Looks like we need to go to the COCAD initial approach fix. So notice here, and down on the FMS, we have a little button that says, do you want to connect Smyra and COCAD? We ask you, it's the next logical thing. We call this our FMS butler, that little button in the lower left corner there. It kind of gives you the options. So you can connect it, or you can scroll down and just go direct to COCAD, which bypass the gap. Or you can scroll down to any other waypoint if you're cleared to another waypoint further down in the approach, and you can just activate that leg. So we make it very easy, and it's all in plain English. You don't have to, again, memorize. And then here you can just activate the approach with the butler, in which case it'll close the gap for you. So it makes it a lot simpler to execute a transition to an approach. If you're doing vectors to final, notice you've got the gap here. In this case, we wouldn't close you'd be vectored until it was time to get cleared onto the next waypoint, and then of course you just fly direct. So this FMS butler provides a way of keeping you ahead of the FMS. On the IFD, it shows up on the IFD540, it shows up right there on the flight plan page. Basically gives you one button, context-sensitive shortcut for common operations. Again, remember the focus here is how can we reduce the button count and the head down time. This FMS butler is going to activate approaches, enable a mist, allow you to exit a hold, continue a hold, etc. Here we are in activating a mist. Notice down here in the lower left, it says activate the mist. You just push the button and it'll activate it. If you need to exit a hold, you say you're flying in a hold, here you are. Hit the exit button and out you go, or you can continue to hold. Our engineers came up with a really elegant way to meet the requirements of this TAA study. Easier to navigate with the page and tab user interface. It's no nested menus, clearly labeled buttons, eliminates the need for memorizing, reduces the amount of do-overs. We got easy airway flight planning. You'd literally select an airway, select an exit point, and it'll load all the intermediates. I mentioned geofill. It's going to reduce the keystrokes required, make it much easier to change your IFL routing on the fly, even in a heavy workload situation. That makes all the difference in the world. We also do station identifier lookups for comm radio, so you know who you're talking to before you push to talk. I'll show you a little bit of that. As we talk about specifically the IFD540, that's our new panel-mounted GPS nav comms, the 540 and 440. They're, again, based on R9, and you can see here's the R9 system. Each one of these displays is basically a card cage, and it's got these little blades in there. And this is, notice, a VHF blade, so it's got a comm, a nav, a glide slope, and a marker beacon antenna on it. And then you've got, this is a GPS blade, and those just plug right into the back. There's also what we call an ACR, a computer resource. This is a double wide. In case of the R9, there's an Adahars blade in there as well. And each of these boxes are identically populated, and they work really well. They've got the page and tab user interface. So we've taken all that technology and put it into the standard mark width box, so we can retrofit it into all the lion's share of airplanes out in the GA world. It's got the same dual comm, dual nav in each box. Each box will receive dual nav and dual comm. You can transmit on one, but you can actually receive on 2 channels. 10-watt comms with 16-watt option. Have the same page and tab user interface, but we've added touchscreen capability now. So we've got what we call hybrid touch. That means we've got all the knobs and buttons, but we also have touchscreen. So it gives you the choice. And then, of course, the 440 is just a smaller version of the 540. One big advantage with these systems is that they're plug and play for existing 530 and 430, and there's a ton of those out in the world. If you have a 530 today, you could literally pull it out, plug in a 540. We can use the same connector, the same tray, the same wiring, slide in replacement. If it's a 530W, you can put in a 540 and it'll behave as a wash unit. Same with the 440 into a 430 rack. So there's a few additional functions you might want to wire in, but if you want similar functionality, you'll get a few things anyway. Simple plug and play makes it really more affordable from an installation point of view, so you're not tearing up your panel. You don't need more panel space. It uses the exact same wiring and connectors, etc. We also leverage the byte flight data bus of R9. In R9 system, that's the data bus that allows these boxes to talk to one another. And also inside the card cage, each of these blades talks to one another via byte flight. In a multi-unit installation like you see here, we use that byte flight in place of a crosstalk, and that allows us to do the cross-syncing capability, so you can load an FMS load the FMS with a flight plan on one box, and it will automatically cross-fill it to the other for redundancy. And you can do this keyboard convenience features, which is really cool. That allows you to bring up a QWERTY keyboard on one box and have it drive the inputs into the FMS on the other. It's like having a virtually larger display that way. From the outset, we knew that Wi-Fi and Bluetooth would be important as we move into with all the tablets and iPads and everything coming into the cockpit. So we have already certified all the 540s and will certify the 440 with integrated Wi-Fi and Bluetooth. So the hardware is in all the boxes already. It's hardware enabled. We have a software release coming shortly, and it will enable the first of many to come features with using Wi-Fi and Bluetooth. You don't need to add an extra box and add a bunch of extra wires. It's all built in. The antenna is actually in behind the logo, right on the faceplate there. So it's not only Bluetooth, it's also Wi-Fi, and we think there's some real benefits to having both. No one else has that. Some of these I'm going to whip through because they might be a little bit repetitive, but geofill, again, intelligently predicts based on distance and reduces data entry by as much as 75%. Hybrid touch, virtually anything you can do on the knobs and buttons, you can do on the touch screen and vice versa. There are a few exceptions. Obviously panning and rubber banding and stuff like that are touch only. We use a capacitive touchscreen technology. We're the only touchscreen box out there that's certified that uses multi-touch technology. That means we can do the pinch zoom like you're used to on your iPad or your Android or your iPhone. So now you can reach up and just pinch zoom. You can still spin this knob over here and range in and out. Remember, it's hybrid touch. You can either do it on the knob or you can do it on the touch screen. But the pinch zoom is really nice, especially if you're flying with an iPad on your kneeboard there and you're constantly zooming in with it. You can reach up and you'll want to do the same thing on this. Rubber banding is a touch-only function. You can touch any leg in the flight plan, stretch it anywhere you want, and let go of it. It'll ask you, do you want to snap to the nearest nav aid, in this case, Orange Municipal Airport, or do you want it right where your finger really is, in which case it will automatically create a rubber band waypoint in the flight plan for you. While we show the active leg as magenta, we also show the next leg as a candy cane or a segmented magenta and white. And on a dog leg like this, that's not that big a deal, but when you're entering holds, it makes it really obvious what you're going to do next. Am I entering a teardrop or am I entering a parallel hold? The next leg is really a cool innovation. If you're interfaced to a compatible fuel totalizer, we'll show the fuel range rings on the map. If you get within your 45-minute reserve, those will turn yellow. We've also integrated a full color contour terrain base map along with color coordinated terrain alerting capability. So as you see up here, if you get within 1,000 feet of the terrain, it'll turn yellow. If it's within 100 feet below you or anything above you, is going to be red. So you'll get terrain and you'll get the associated alerting and messaging associated with that. In addition, we've got algorithms that project out in time, 60 and 30 seconds, and they give you this solid yellow or solid red flashlight beam if you're going to impact terrain within 60 seconds, or it'll turn red within 30 seconds, and you'll get oral alerts and message alerts, which I don't show here. Here you can see those message alerts here in the corner. We do the same thing with the obstacle database. We'll put what we call a threat bubble over an obstacle if you're within 5 miles and 2,000 feet vertically. If you get 3 miles, within 3 miles to these parameters here, you'll turn yellow, and then it'll finally turn red. And again, you'll get the appropriate audible and visual alerting as well. Again, really nice features that help the pilot out in a technically advanced aircraft. We can put vertical constraints on waypoints, either as part of a published procedure, or you can just manually enter them, and we'll show a top of descent marker here. If you bring your data block out, it'll give you the vertical speed required to get to this waypoint. In this case, I want to be at Avidyne at 4,000 feet. Here's my top of descent. When I get there, I start my descent, and I'm going to nail it when I get there. The page and tab user interface, we got the 3 main functions, FMS, map, and aux. As it shows here, the FMS, we're on the FMS page. I've got the plainly labeled tabs. Again, comparing that to the 530 chapter and page, you don't really know where you're going until you get there. If we jump over to the map page, notice there's only 2 tabs, one for map and one for chart. Here we're looking at the chart. And compare that page and tab user interface to even the GTN, as I mentioned earlier. It's more of an app-based graphical user interface. You kind of go into the flight plan app and you load the flight plan. Then you come back to home and then you go to the map app and you mess around in there, and then you come back and go to the weather app or the terrain app. And you're kind of diving down the bunny hole and coming back up to the menu. With our system, with the 540, you can get to virtually any page in 1 or 2 clicks. So we got a very flat menuing system. Again, designed to reduce head down time and get the pilot paying attention to flying versus figuring out where stuff is in the box. We do station ID lookups not only for the active frequency, but for also any standby frequencies. We have a frequency list button that if you push it, it will bring out a list. There's 3 tabs on it: airport, en route, and recent. Before you depart, you go to that airport tab, and all the departure airport frequencies will be listed in the order you need them. All you have to do is double-click on the frequency and move it over into the standby window. When you're ready for it, just flip-flop it into the active. Once you climb out, you go to the En route tab, and all your center frequencies, flight service, all those will be listed for you on the En route tab. When you get within 40 miles of your destination, go back to the airport tab. It'll have automatically loaded your arrival airport frequencies in the order you need them so you can perform your arrival. There's also a recent tab that'll kind of keep a running scratch pad of all the tabs all the frequencies that you've entered. I mentioned airways. You just push in on this, we call this the FMS button here. You push in on it, this menu pops up. You scroll down, select the airway you want, select an exit point. We'll give you what we call an FMS preview. Will show right out on the screen. As you scroll through the list of exit points, it'll actually build the flight plan out for you and then load all those waypoints into the flight plan without having to manually look them all up and figure out how to spell them, all that. The procedure button allows you to load procedures, load an approach. When you push that button, the map will automatically scroll to your destination airport, and as you move through this list, of course in this case there's only 2 different options, but as you scroll through these, we'll actually show a preview of the approach before you select it. Once you select the approach, you select the transition point. Am I vectors to final? Am I going to the initial approach fix? And off you go. We offer a free PC-based simulator of the 540. You can go to our website and download it for free. We also have an iPad app that you can go to the App Store on iTunes and download. We just put up the iOS 8 compatible version. Those are both free of charge. We don't charge for them. I encourage you to go download those and kind of get familiar with it. If it's something you're interested in, you'll find it incredibly easy to use. Don't have time here to take you through it, but it's a good way to do personal training as well. So real quick, 540, hybrid touch. Gives you the best of both worlds, touch screen and knobs and buttons. Multi-touch, we got pinch zoom capability. We're plug and play for the 530-430, so we're slide-in replacements. That lowers your install cost if you have one of those boxes already. The page and tab user interface allows you to get to any page in 1 or 2 clicks. Geofill, easier data entry, easy airway flight plan entry, the convenience keyboard. Again, all this stuff combines to reduce head down time and eliminate the memorization. We did announce a couple weeks ago our MLB 100, which is a ADS-B FISB receiver, so you can get the free weather on your 540 and some of our other displays. That'll be available in the early 2015. We got a lot of questions about that. What are you doing for ADS-B in? We also have a ADS-B out transponder, a AXP340 that meets the mandate for ADS-B out. The pricing on the 540 is $16,995. It's now certified. The smaller 440 will be out in the early part of 2015. These products come with a 1-year warranty, but actually it's a 3-year warranty because once you sign up and register your warranty, we're going to give you 2 free years. So it's really a 3-year warranty. As Jeff mentioned at the top, for those of you that joined us tonight, I'm going to be sending you a coupon in the email for savings of up to $1,000 if you purchase a 540 by the end of this month. If you can't do it by the end of this month, you can still save $500 if you do it by the end of the year. So I encourage you to take advantage of that. It's a smoking good deal, and I think you're going to just love the product. It's again, I think it's second to none in the market. So again, meeting the challenge of TAA. Reducing keystrokes, memorization. We got it more intuitive, less head down time. We designed to enhance safety, easier to use. We think it's more fun. It makes flying more fun. With that, I guess we'll open it up, Jeff, to any questions.
Absolutely. And so everybody, you have a chat section there if you'd like to ask some questions. And we also I've been sent some via both the email and the Q&A section. So I'll start going through some of those, but anyone who wants to type something in on chat, we'll address that there. So one of the first things that I have, Tom, and again, thank you so much. Really interesting presentation. I'm certainly looking forward of going to be getting one for my plane. So one of the questions we have here is, what you mentioned that it's a slide-in replacement, But you did mention that there's some other features that you can take advantage of if you do a little more than simply slide it in. Can you talk about what other features are available if you do that?
Yeah, the two that come to mind are, I mentioned the TAWS, the terrain alerting capability. It's not really a certified TAWS, but it's kind of everything but the TSO sticker, basically. But to get the audible alerts, again, if you're replacing a 530 that didn't have TAWS, you would need to add a wire up to the audio panel so you could hear the audible alerts. You don't have to, but we recommend that you do. If you had a 530 that did have TAWS, then that wire is there. So while it's plug and play, that's one extra wire you might need to add so you can take advantage of the oral alert. We also have an option. I mentioned that these comm radios can tune the active and the standby comm frequency. If you have the Avidyne audio panel that has a monitor button, you can actually monitor the standby. It's like having 1.5 radios in each box. So in order to listen to that standby radio, you're going to have to add a wire from the 530 rack up to the audio panel. If you're putting in our audio panel, then you're going to just add it with that anyway. So that's the two that I can think of. It's just to take advantage of a couple extra, cool features.
Okay, we have a couple questions that have come in directly before I go on to the rest of my list. One of them is, how is the database updated?
I had a slide in there, and I think I yanked it out at the last minute, but basically there's a USB port on the front bezel of the 540 and the 440, and we use a standard USB jump drive, kind of commercially available. You go to we use Jeppesen data for nav, charts, and obstacles. You download onto your jump drive, you take it out to the airplane, plug it in. At startup, it's going to go out and recognize. It's going to say, oh, I see you have a jump drive. Would you like to? You've got a couple of options. You can upload your nav data, your charts, and your obstacle data. It also gives you the option, I didn't talk about this, but you can download flight log data. It will actually, we kind of keep track of a lot of metrics, keep track of button pushes. We monitor line voltage for sagging. We kind of keep an event log in there. So how many times with legacy avionics have you gone flying and something glitches and you come back to your dealer and you tell the dealer, hey, I had a problem while I was flying, and the dealer for the life of him cannot replicate the problem. So you're left, scratching your head there. The dealer is so, or a lot of times they'll pull the box out and ship it in and nobody can find it. With these flight logs now, what we can do, we can download those. The dealer can email them to us. We can analyze them. And before you even ship the box back and have some no trouble found or something, we can either identify or dispel whether there's really a problem. And the dealers just love that because it, again, and of course customers do too, because it keeps you flying and kind of helps with your sanity. I knew I saw something. It helps us identify something that might be intermittent. So that's a nice feature. It also, we can download configuration. So let's say you've got your box all configured, and maybe you add a second box, or maybe the box has to come back for maintenance and you get an exchange. You can have all your configuration on a jump drive. So if you put a different box in, it'll reprogram it without having to manually reconfigure all your preferences and all your settings. So the USB is really versatile in that way.
Okay, another question which I think probably needs a little clarification on, but someone had asked about integration with the 540, 440 and the GTX 330 ES for any folks that have that. Now, I understand the question was about ADSB in and out, and for clarity, obviously the GTX 330 ES is only an ADSB out unit. It doesn't actually provide any ADSB in features directly. But any information on that for this gentleman?
Yes, the short answer is it will not communicate with the well, it's not certified with the GTX 330 ES. We have compatible interface to the 330 ES, but we don't control the STC of the 330 ES. Garmin does, and at least in the short term, we believe it'll be up to them to add the 540 to their STC. So I don't think that's in the cards in the short term. If you have an ES, let's say you have a 530 and an ES and you're interested in upgrading to a 540, the best thing to do is give us a call or talk to your dealer and all three of us communicate, and we can work out a deal where we trade up your GTX 330 for an Avidyne transponder that where the two systems are certified together. So that's kind of the long-winded answer, but that will give you ADB out with the Avidyne solution.
Actually, it's a great lead-in because another question that we have on the line has to do with those trade-ups, and they're curious about any information on trade-ups from 530s or 430s.
Well, Avidyne doesn't take the trade-ins directly, but virtually every dealer we've talked to will happily take a 530 or 530W on trade, and I'm sure a GTX as well. They're able to sell those in the secondary markets, or they even sell them offshore. But there's still a really good market for used equipment. There will always be a market for secondary, a secondary market for avionics. And they're holding their value pretty well. So if that's something you're interested in, we can connect you with dealers that are doing that very thing.
Hey, Tom, another question that we have here has, what about the idea of being able to do any kind of flight planning at home and bringing that in? And I'm sure you probably got a smile with a lot of surprises planned for the future. What about what you can talk about?
Yeah, I'm reluctant to make any promises at this point, but you use your imagination a little bit with the fact that we've got Bluetooth and Wi-Fi. That is exactly the road we're going down, to interface with the tablets, the iPads and such, where now you can use popular applications on your iPad or other devices and do all your flight planning at home, come out to the airplane, squirt that flight plan into the box, and off you go. And then that's also a two-way street where you can transfer information off the panel-mounted box into the tablet as well. So that's the direction we're going. That's the reason we put Wi-Fi and Bluetooth in these boxes. I can't really say much more about specific plans until we're ready to deliver, but you should be hearing about those after the first of the year here shortly.
Great. And the last question is, you mentioned a Bluetooth keyboard or the ability to use another Bluetooth keyboard. Is that something available out of the gate, and can you talk a little bit about that?
Well, it's not available yet, but again, we'll enable those features with the kind of in the early software release, the first software release we do. Our intent is to use commercially available. Remember, these don't have to be certified. You can, Velcro it to your yoke, or you can put it on a wrist strap, or put it on your knee board, and have a remote keyboard that syncs up via Bluetooth. So that's kind of one of the early things we wanted to get out, because it's something we can do pretty quickly, and it's again, because it's wireless, it's not bolted into the airplane, therefore we don't have the certification limitations. And the way we built the firewall in the 540, it's really ingenious the way they've done it, so that allows us to do a lot of these things in a much shorter time than what we're familiar with it takes to do normal certified avionics. So we can add some of these cool new features in a pretty timely fashion.
Yeah, that seems pretty cool, especially considering if you can kind of buy any Bluetooth keyboard that you want. I know there's gaming units, there's little ones that you could probably even easily put on a stick and use it even with your thumb. So that sounds pretty cool.
Yeah, so it remains to be seen how that rolls out. Which ones are going to be, whether they need to be each one by model approved, or whether we can kind of have it open. I don't know that offhand today, but that kind of takes you down that path of kind of some of the cool things we can do. And having, like the GTN has a Bluetooth interface. We also have Wi-Fi in our box, and Wi-Fi has some other advantages. Long term, you can imagine, taxing up to an FBO and syncing to Wi-Fi and getting some data exchange. So things that, Bluetooth is kind of good on a one-on-one device, but Wi-Fi's got a much wider bandwidth and better range too. So there's some other advantages to that.
Absolutely. Well, that's we're at the pretty much the end of our time, but it's also the end of the questions that we have. And so I'd like to thank Tom again for joining us and being part of the Social Flight webinar series that we have. Again, our goal is to provide as much education as possible and anything that helps support general aviation. I'd encourage anyone, if you're not already a Social Flight member, it's just free. It's an app, and it's the website at socialflight.com. And please spread the word, because the more folks that we have, the more events are in there for everyone, the more organizations get supported, and we are all here to promote general aviation. So thanks again, Tom.
You're welcome.